A Formula One driver can feel 6.5 times their body weight in a corner. This happens while the car is changing direction at speed, not just when it accelerates straight ahead. The driver is inside the car, so the load passes through both machine and body. In the turn, lateral force pushes the car and driver outward. Lateral force means sideways force, and it grows sharply when speed and cornering combine. That load can reach about 6.5 times body weight. At that level, cornering becomes a major physical challenge for the driver. The shock is simple. A racing turn can briefly become a multiple body weight event. The car stays on track because the tires and downforce keep it planted through the corner. Cystic fibrosis was once described as a childhood death sentence. Today, it is treatable. Cystic fibrosis is an inherited disease that makes thick mucus build up in the lungs and other organs. That buildup makes breathing and digestion harder over time. New drugs changed the disease at its source. They help the faulty protein work better, so mucus becomes less thick and easier to clear. That shift changed treatment from only easing symptoms to targeting the underlying problem. Families could see a real change in daily care and outlook. That is why a diagnosis no longer carries the same ending it once did. For many families, the word now comes with treatment, monitoring, and hope. Penicillin was discovered in 1929, then largely forgotten for about 10 years. A major medical breakthrough sat in the background instead of changing treatment. That gap matters because discovery is only the first step. A substance can be found, but its value still has to be recognized and tested. Penicillin later proved important because it had an antibiotic effect. An antibiotic is a substance that stops bacteria from growing. Once that effect was taken seriously, the old finding gained medical significance. The same discovery now pointed to a practical way to fight bacterial infection. Penicillin shows that discovery alone does not guarantee impact. Sometimes a result sits unnoticed until evidence makes its use impossible to miss. Condensed matter physicist Zachary Fiske once hid chemistry experiments from his father. He was already drawn to science, but chemistry was the interest he kept out of sight. His father disapproved of that interest, so the experiments had to happen in secret. That pressure did not erase curiosity. It pushed his first hands-on science away from approval and into private practice. The result was a future physicist whose earliest experiments began out of view, before the technical career that came later. Forensic scientist Luke S. May was nicknamed America's Sherlock Holmes. That nickname came from his detective-style reputation. May worked in forensic science where small traces can answer larger questions. The job depends on observation, comparison, and careful interpretation of evidence. That Sherlock comparison points to investigation, not fiction. He earned it because his work followed clues through evidence, step by step, like a case built from facts. The result was a reputation built on solving problems through forensic analysis. People saw him as an investigator whose science could narrow uncertainty. So the nickname means more than a clever comparison. It marks Luke S. May as a scientist whose evidence work made investigation feel like detective work. Diana Cowan, known as a YouTuber, has an asteroid named after her. Cowan is better known online than in an observatory. Her work reaches millions through video, not through telescope time. An asteroid naming is a formal recognition, not ownership. In astronomy, a name can honor a person whose work matters to the field. That recognition moved her name from the internet into the solar system. The asteroid now carries Diana Cowan's name as a permanent scientific label. It is a rare kind of honor, a public science communicator marked on a body beyond Earth. Her name now belongs to space as well as to video. Fossils from British Columbia and Washington were most similar to an Australian green lacewing. The fossils are called Atomsocrisa, and paleontologists compared preserved features from North America with lacewings from Australia. In paleontology, similarity means comparing shape and structure, not just where something was found. Here, that comparison linked these fossils to an Australian green lacewing. That makes the match cross-continental. Fossils from British Columbia and Washington point to a living group far outside North America. The result is a fossil clue that reaches across the world, showing a biological connection that geography alone would not predict. Intersex healthcare is not one fixed plan. It depends on the physical characteristics a person has. Intersex is a broad term for people whose bodies do not fit a single typical pattern. That means the same label can include different physical traits. So clinicians look at the body in front of them, not a template. The care plan depends on which traits are present and what those traits mean medically. That creates individualized care instead of a single uniform approach. Two people can share the same broad category and still need different medical decisions. The result is simple: biology guides the healthcare needs. The right care comes from the specific physical characteristics, not one template for everyone.